Building a NAS using a Raspberry Pi 4 might be a bad idea after all, and here's why. Hey, my name is Nick, and today we're going to discuss why building a Raspberry Pi 4 NAS is maybe not the best option for you. There are a lot of videos on YouTube about Pi 4 NAS systems, and I myself had a Pi 4 NAS running for the longest time. Well, first of all, you could opt for a ready-to-go solution from, let's say, QNAP, Synology, or Western Digital. I started with one of those years ago and was pretty happy with it until there were no more updates for the device. The pain started when my modern operating systems refused to connect to it because it only provided the completely outdated and insecure SMB1 protocol. These ready-to-go NAS solutions have one problem from my point of view. They are closed source, have heaps of services running, and I have no idea how long I will get updates. So my idea was to take a Raspberry Pi 4 and build the most simple NAS that I can come up with. In this video, I want to show you how to build this super simple NAS. And first of all, we're going to set up the Raspberry Pi 4 using the headless mode, so you don't have to use any peripherals like monitors or keyboards. You just need a LAN connection and a power adapter and your SD card and obviously your Raspberry. After that, we will install the software that we need and start testing and see how the Raspberry Pi 4 handles our NAS needs in practice. So we're going to download the Raspberry Pi operating system. We're going to go for a manual installation. Going to see all download options over here, and we're going to opt for the 60-bit version of Raspberry Pi OS. We're going to pick the light version because we don't need any software, just the regular operating system. We downloaded it, and I already did that before, so yeah, just download it and you're good to go. After that, I'm using Etcher to flash this image to my USB device. I'm picking the image over here, select the target, make sure you select the right target because otherwise you will destroy your machine. And yeah, just enter your password and flash the device. All right, now that the flash is complete, you can switch to the terminal. You may have to unplug and replug the USB device that holds your SD card for it to auto mount. And then you can change the directory to the directory that the bootfs is located. I'm running Fedora over here, so in my case it's run media nic and bootfs. Over here we're going to touch a file called SSH, which is the indicator for the SSH server to come up on first boot. And we have to create a file, userconf, with a password in it. So over here my password that I pick is Raspberry, and we have to pipe it to OpenSSL and a password algorithm, which is SHA 512 as far as I remember. And we're going to read from standard in, and we're going to write this to userconf. Now that we have a userconf file, we're going to edit it and just add a username and a colon in front of this encrypted password. So I'm entering pi colon and saving the file. All right, now you have your SD card ready with the operating system. Plug it into your Raspberry Pi. I have mine over here. And this should boot straight into the operating system. This is a headless installation. You have your SSH file on here, so the SSH service will be starting automatically. You have your userconf file on here with the user pi and the encrypted password that we just set. So this thingy, it should just boot up fine. And let's go back to the terminal and see if we can find it. All right, now that we have the Raspberry Pi set up in our network, we have to find it, and I'm using Nmap to scan my network using a ping scan, and I'm filtering the results by the term Raspberry because the Raspberry will show on your local network with the name of Raspberry Pi. And there it is. So now we have the IP address that we can connect to, and we're just going to do that. So we're using the user pi over here that we just set in the userconf file, and we're going to enter Raspberry as the password that we chose, and boom, we're in. Headless. Oh, I love it. So now let's do a quick update, upgrade, and after that reboot the machine so we have a beautifully upgraded, fresh running system. Alright, now that we have a running Raspberry Pi 4, let's install the software that we need to get a NAS up and running, and also install the software that provides encryption. Alright, let's talk about the performance of the cypher that we're going to use. We're going to use a cypher that has been built for low-end devices. It's called Adiantum. Just look it up, what the history of that is. It is, yeah, something that should be suitable for low-end devices. Over here you see my computer that I'm working with. I'm using XChacha20 and XChacha12, which is basically the number of times the randomness is influenced. Whatever. These figures you see over here are not 100% precise. In fact, they're pretty much half of what is normal, but I am encoding this video right now on the fly, 4K x64, 60 frames per second. That's why the performance is that bad. So let's go back to the Raspberry Pi and see the corresponding performance of the Raspberry. Before we can do that, we have to install the tools that we need for that. So I'm going to install Encrypted setup, and I'm also going to install Samba because we need the SMB protocol and the Samba package. Alright, so now that we are all set, let's execute the same exact command that we just executed on my main machine, which is a Ryzen 2700X. It's a few years old, but anyway, it runs my Linux just fine over here. So this is Chacha20, which is pretty brutal, and I think Chacha12 should be enough over here. Alright, nice. Now we know the performance of the Raspberry is pretty bad, but it's still okay-ish. And we installed Samba and Encrypted setup. So now let's configure Samba real quick and get the pretty much the easiest NAS going there is. So everything is installed. Let's check our block devices. So as you can see over here, the drive that I attached to my Raspberry Pi 4 shows up as SDA1, and I'm going to mount this device to a folder I call SanDisk Extreme. It is a fast SSD, so anything that is related to congestion later on will not be the problem of my hard drive. If you try to use the MMC block device in there, it's just gonna choke all the time. Don't use SSDs that are not SSDs. Don't use SD cards. Anyway, so we mounted the SanDisk Extreme, and now we're going to configure the the SMB conf. And as you can see over here, I'm struggling because I used cursor keys to move around, and then this shit happens, and I'm like, damn it, this is not VI improved, this is just the regular VI. So I'm trying Vim over here. It's not there. So let's install Vim. Boom, this is Ubuntu, not Fedora, so please use apt. Now that I installed Vim, we can go back to edit the SMB conf file, and Vim is a replacement for VI, so we can just basically go back to VI. And boom, look at this, beautiful. Let's go back and enter the little bit of configuration that we need to get going. So we will create a share that is called test. The path will be home pi SanDisk extreme. The folder that we just created and mounted our external hard drive to, it's going to be browsable, so we can see it in our Explorer or whatever you are using. And obviously we need it to be writable, so we can write files to it. So yeah, that's pretty much it. That is the most basic configuration. Next thing that we are going to do is we have to create an Samba user. So we're going to use smb passwd add pi. We're just going to give it a password that we need to connect to the share. And the last thing that we have to do is we're going to restart the Samba services, so the new configuration file will be in effect. And we can connect to our NAS. Basically, that's it. Now we have a NAS. Yeehaw! Nice. All right, now our simple NAS should be up and running already. But let's talk about encryption for a second again, because the performance tests I'm going to do later on, I want to do them using an encrypted file system and an unencrypted file system, so we can compare these. So I'm going to show you now how to provide an encrypted file system to your NAS. All right, let's talk about encryption. Before we do that, let's unmount the SanDisk mount that we mounted previously. So now our device is not mounted anymore. And now we can use crypt setup to encrypt this device using ChaCha12 and Adiantum as the cipher. So we have to provide a capital letter yes to do that. Then we have to choose a passphrase and verify the passphrase for the encrypted device. And that's it. So we're telling the crypt tools to open the device located at SDA1 and use the name SanDisk is extreme as the mapped device name. Now we have to enter the passphrase, and now we have this encrypted device open. Next, we need to mount this device to the directory that we just created, but oops, look at this. I couldn't mount it because there is no file system yet. We basically just encrypted the hard drive, but there is no file system on that thingy yet. After opening it, you have to use mkfs to just create a file system, and boom, now we can mount it. Here we go. There's just one thing, please change the owner of the directory to pi. Otherwise you will run into trouble because you cannot write to this folder. Now you can. As you can see, I'm touching a file over here. And there it is. And I'm also able to remove it. All right, finally we can start testing. There are 3 tests that I did. First of all, I'm using DD to just directly write a very large, slightly above 60 gigabyte, a large file onto the file system without any network or whatever. So that is the first test to see how fast can I write data to the file system and how much load will this put on my system. The second test will be copying this large file using the NAS feature. So I'm using the Samba share to just copy this large file to the Raspberry Pi. And the third test will be pretty much the same amount of data, 60 something gigabytes, but 10,000 files. So the difference is one large file without network, one large file with network, and then 1,000, 10,000 small files that in sum are the same amount. And these are the 3 tests that I'm going to do. And I'm going to do these tests first on an unencrypted share, and after that on an encrypted share. Let's see how it goes. All right, so the tests. We're going to look at the tests and see how much load these 3 tests put on the system. I also measured the consumption, the power consumption. It's not really that important. It's just another figure that I want to share. Yeah, so the first thing is that in idle, the Raspberry Pi has 0 load, obviously, and it consumed 3.8 watts of power. Now I started with the first 3 tests, which were DD a large file onto the file system, then use SMB to copy a large file onto the file system, and then use SMB to copy 10,000 files onto that file system. And that was already a surprise because DD took the system to a load of approximately 1. Copying the large SMB file, the load got as high as the average load, that is, yeah, just keep that in mind, 2.46. And using copying 10,000 files, the load decreased to 1.67. And that shows me that there is a lot of network overhead going on when you use SMB. The system was just busy talking SMB and not writing files. So now that I switched to the encrypted file system, the numbers went up, obviously. So now DD had a load of 2.6 compared to 1, which is still fine on a 4-core system because you should stay below 4 on average. But using SMB to copy the large file, so there's not a lot of SMB overhead, just, copying the file to the system, resulted in an average load of almost 5. Bam, system broken, system congested. This should not happen. When I copied the 10,000 files, the load was only 2.61, which is fine because once again, the system was not busy writing files, it was busy talking SMB. All right, those were the test results. So what do you think? In my opinion, the Raspberry Pi 4 is not suitable for an encrypted NAS. It will choke at some point. And just to prove that, I have a little bonus for you guys. There is this very nice tool, it's called Syncthing, and that is basically like a private torrent network. Anyway, I also thought about using my Raspberry Pi 4 as a Syncthing client, and let me just show you what happened when I used Raspberry Pi 4 on Syncthing. All right, here are my results of the system's load using Syncthing. When I used Syncthing on the unencrypted device, it already went above 5. But when I used the encrypted device to write to using Syncthing, I went well above 6. So these are numbers that you don't want to see on a 4-core system. It's absolutely ridiculous. There is congestion. This is not good. Once again, you can run Syncthing on a Raspberry Pi 4. It works. It will just choke. It's something that you might not want to have. As a last figure, I want to show you the load on my current system, which is a Celeron N5105 processor. I just got myself another mini computer to set up my home server, my home NAS. My home NAS is not running on Raspberry Pi 4 anymore. And now it is like a very nice system that can handle Syncthing without a problem. It can handle encryption without a problem. And the idle power consumption is half of the idle power consumption of the Raspberry Pi 4. Believe it or not, I love this machine. It's a Mealy Quieter 3Q. Yeah, I'm really happy with that thingy. So yeah, that is my conclusion. Raspberry Pi 4 NAS encryption, not cool. I even tried Open Media Vault to see if I maybe did something wrong and I just proper NAS software. Same results. Raspberry Pi was choking. Encryption is not a thing. And I hope you liked the video, and I'll see you. Maybe, maybe not, because I don't do videos on a regular basis. It's just that this thing was bothering me. Jesus, Raspberry Pi 4 NAS. Not like this. Bye-bye.